I'm at Airbus Defence and Space in Stevenage, which is a really important place because just over my shoulder is the Solar Orbiter spacecraft. Solar Orbiter is a mission that aims to understand something called the heliosphere, basically a huge bubble of electrically charged gas and magnetic field generated by the sun. We want to know how the heliosphere is created and how it changes over time.
It's really exciting that as well as Solar Orbiter, we have the Parker Solar Probe launch happening in the same time frame. This means we're going to have 2 spacecraft looking at the sun, which gives us absolutely unprecedented viewing. And I think it goes to show how important it is to understand the sun that both NASA and ESA have decided to put their resources into really studying it up close. Solar Orbiter is going to go to 0.3 astronomical units, which is 30% of the Sun-Earth distance, and it's just inside the orbit of Mercury.
We're going to be collecting a huge range of data, and it can kind of be split up into 2 camps. So one set of instruments will look at the sun and take images using a variety of wavelengths of light, from say visible into extreme ultraviolet, and the other set of instruments will measure the emissions that are coming over the spacecraft. So it will be sniffing the material and the magnetic fields coming from the sun. We hope Solar Orbiter will be able to answer the origin of the sun's activity, but not only that, but how the activity and the emissions from the sun propagate and evolve throughout the solar system. Getting that close to the sun means that Solar Orbiter will be in some pretty extreme conditions. The sunward facing side will heat up to around 500 degrees Celsius, and it will be blasted with intense solar radiation. To help Solar Orbiter withstand this incredible heat, a new heat shield has been built. It was a challenge to build this heat shield, and a new material had to be developed called Solar Black. It's made of crushed charcoal animal bones, and it's a brilliant substance because it conducts electricity, so the shield doesn't get statically charged, which could damage the spacecraft, and also it won't degrade over time.
The magnetometer measures the magnetic field. If we know which way the magnetic field is pointing, we know which way the charged particles are expanding out into space. We are going to be out on a boom at the back of the spacecraft, so counterintuitively we're going to get very cold because we are never in the sun's illumination. So the boom will go down to temperatures of -140, but then when we go past Venus, it's going to go up to +80, which is a huge range of temperatures.
One of the sensors on board Solar Orbiter is the electron analyzer. Really important because it's going to study electrons and the other composition of the solar wind. So we vibration tested it to make sure it will withstand the launch. We cycled it through extreme temperatures so that it will be able to survive in space. We even fired electrons at it to test the sensitivity and the performance of the instrument.
I think it's going to be a really nervous time around launch, but also very exciting. This is something that I have physically put together. I have touched this object, and now it's going to go up into space.
It's hard to convey just how exciting it is and how much discovery we will get from this amazing mission. So we're going up to see the sun up close. Finally, it's hugely exciting.